Hello, my name is Fredrik Heintz. I'm an associate professor of computer science at Linköping University, where I do research on artificial intelligence, especially really much interested in about how can we use AI in a trustworthy and sustainable manner to solve real-world problems. So today I'm going to talk about privacy-preserving synthetic data generation. So the outline of my talk is that I will start to describe what is trustworthy AI and what is sustainable AI and why is this necessary. Then we will go on, and as you all probably know, real data is very central to modern AI. So basically, this kind of data-driven methods require that we have accurate, real data. And of course, this Data Innovation Summit is very much focused on the question of data. However, using this kind of real data introduces a number of major concerns, such as privacy, fairness, bias, and so on. And I will therefore argue that one set of techniques or one approach to deal with this, especially when it comes to dealing with privacy, is to use synthetic data, which allows us to basically generate data which is similar enough to real data, but it is not real data and it's not connected to any real individuals, so therefore it's private. You can also use it to improve fairness and reduce bias and so on, but that's not the point of this talk. Also, of course, everyone knows that AI is being used in a wide range of applications. So I would argue that the major improvements that we've seen the last couple of years is around computer vision, voice recognition, and natural language processing. So basically, analyzing and trying to figure out the information related to images, video, speech, text, and so on. But of course also large-scale data in general. And of course one common denominator here is that all of them depend on access to real data and to build models from this real data and then using these models to do interesting things. At the same time, we have this especially push in Europe when it comes to trustworthy AI. That Europe has taken a very clear position that yes, we do want AI. AI is very important. However, we don't want any AI. We want AI that we can really trust and that works for us humans. So what we want is what we usually say is human-centered, trustworthy AI, which means that AI is not a goal in itself, but rather a means to improve the situation for us as individuals and consumers and citizens and so on and so forth. And I've been part of the European Commission high-level expert group, where we have developed ethical guidelines for trustworthy AI. And the way we defined it, in order to be trustworthy, an AI system has to satisfy the legal requirements and follow the rules and regulations as applicable. Secondly, it also has to satisfy 4 ethical principles. And finally, which I think is actually one of the most important parts, is that good intentions are not enough, but you actually need to have a robust and safe and secure implementation, so that we can really trust that it both makes the right decision and that it's in a proper implementation. A second thing that I think we have done differently in this high-level expert group is that we have not only stated principles, which many organizations have, but we also set up a number of requirements that the system has to satisfy in order to achieve these principles. And finally, we've also started to work, or actually we have just released an updated version of an assessment list for how you as an organization can convince yourself and others that you actually satisfy these principles. So that's one part, to be trustworthy. The second part, which is work that I've been doing at the AI Sustainability Center, led by Anna Fellende and Lane Grünewald, and there the focus is on how to help organizations to use AI in a positive manner, in an ethical and long-term sustainable manner, which means that we want to reduce the risk of misuse and overuse. We want to make people aware of bias, both in the creator, in the data, and in the algorithms and so on, and also to avoid a pitfall of immature AI. So basically, the center has developed a framework for helping organizations to do this. And this talk is partly based on one of the projects that we are doing in the AI Sustainability Center, which is a joint project between the AI Sustainability Center, Telia Company, Malmö Stad, and Linköping University. But of course, one of these major things, major challenge when it comes to data is bias. So one way of, one kind of common aspect of bias is that the data sets that we have do not represent reality. For example, we have seen a number of issues, for example, with the facial recognition system, which works reasonably well on white males, but then really fail when it comes to, for example, colored women. And this is then often the case that these systems have not been trained on a representative sets of faces and therefore fail on certain important groups. In principle, this is somewhat easy to overcome, namely to collect more and more representative data. But of course, there are other challenges as well. But what's also interesting is that in some cases, the data that we get from reality is not what we want. For example, if we're looking at giving advice on job opportunities by looking at salary information, and of course, the salary information will be biased so that men have a higher tendency or to have higher paying jobs, and jobs with a large portion of women have a tendency to have lower salaries. So in a sense, if we then build our recommendations based on this real salary information, salary data, there is a major risk that our recommendations will be biased due to this. And here it's a much more challenging problem because it's not about collecting more data or improving your data collection, but rather you need to do something else. That you need to actively either choose the data in such a way to reduce the bias, or taking, and of course in any case you need to take a normative stance on what you think is correct and what you think is incorrect, and then in different ways manipulate the data to get the desired statistical properties. And I think that's very interesting. But of course the purpose of this talk is more to focus on privacy. And in our society, privacy and personal integrity is a fundamental. So we have, for example, a legal right to be able to have private conversations, for example, with our medical doctor or with our lawyer and priest and these kind of things. And we have, for example, the right to have a private vote in the democratic system and so on. So privacy and personal integrity is a fundamental part of our society. And this is, but at the same time, we have this need to actually use and access data. So a number of traditional ways of doing this is, for example, through anonymization. So we remove, say, name and phone number and other things that can be seen as personal identifiers. There's also aggregation. So instead of looking at individuals, we look at groups. And of course, we have encryption that allows us to transmit this sensitive data. And of course, there are also methods being developed of how can we do analysis on encrypted data. So we never decrypt the data. So the system that's doing the analysis never can see the real data, but work directly on the encrypted data. But some of the issues here are, for example, if we take aggregation, of course we will lose accuracy because we cannot look at individuals, we can only look at groups, and these groups have to be of a certain size before we can actually analyze them. When it comes to anonymization, it has been shown, for example, that by adding more data sources, it can be easy or at least possible to de-anonymize or to identify individuals. So for example, if you have movement data, so there was a big story in Dagens Nyheter, I believe it was, some time ago, a year ago, half a year ago, or something like that, where they were getting access of basically GPS data, people moving around, and then they could plot this data on a map. And by looking at another further source of information, figuring out who was living in a particular house, so they could see that here is a GPS trace that starts in one building and ends in another building, and it does that regularly. And then they could look up who is living in that house, and then for the people living in that house, they could look up where do they work, and then they could see, oh, this the location of this workplace and the location of this home would identify a person. So by using all these additional data sources, it was possible to identify individuals, even though the kind of original data was anonymous. I mean, there were no personal information associated with the original data that they used. So these are then some issues when it comes to anonymization. And then synthetic data is an alternative approach. So basically, the general idea is that you take the real data, you learn a model of it, or rather, I would say that instead of using the real data, you generate data that should look similar enough to the real data, but should not be attachable to any individual. So in some sense, it can also be seen as a mix of aggregation and anonymization, actually. So that's another very interesting technique. So in the particular use case that we're doing with the AI Sustainability Center, it's about improving the crowd insight product from Telia company, which provides mobility, or rather insights based on mobility data, based on the large number of subscribers that Telia has, and the information that they have about how these subscribers move around and how they travel, for example. So basically the idea is to approximate or to estimate where the users are based on their communication between the mobile phones and the cell towers, and then aggregate this data over millions of different subscribers, and then provide insights for companies and organizations to make better decisions. So it means that all these insights are both anonymized and aggregated, and there has also been some statistical improvements to compensate to get a representative set of data. And the main form of aggregation is based on grids. So basically the country is divided into grid cells of different sizes, and depending on the size, or rather the size is defined in order to make sure that we have a sufficient number of people within the grid to ensure anonymity of the individual people. And then this data can then be used, for example, for travel analysis. So you might have seen these nice presentations and visualizations that they've been showing in TV to be able to provide insight in how the patterns of travel of people in Sweden has changed due to Corona restrictions and recommendations. And the particular use case that we're looking in is to use this crowd insight to help Malmö Stad make better decisions. So for example, some of the things that we could be interested in is, can we help the city estimate or evaluate the effectiveness of different measures? For example, that in order to increase the perceived safety, there might be the situation that in some part of the city, people are not walking around late at night, so we can see that there is not a lot of movement at certain hours. And then you could say that, oh, if we add more light to add more light to this area, we believe that this will increase the perceived safety of this area. And then we can actually try to check this afterwards and see, did this increase the movement of people by adding this traffic lights, or sorry, not traffic lights, but street lights. However, the challenge here is that in order to be able to make that kind of analysis, we need higher levels of granularity. So this 500 by 500 or even 250 by 250 meter grids are not enough to be able to get this level of detail to answer these kind of questions. So therefore, the question that we pose in this project is, can we increase the granularity, both when it comes to the kind of temporal resolution and the spatial resolution, while still being absolutely sure that we maintain this personal integrity and privacy? And the idea, or I mean, the kind of basis for this project is that we would use synthetic data to be able to achieve this. But of course, there are also ethical and legal aspects that are relevant to this. And it's a very natural development on top of the Telia Crowd Insights product. Yeah. So now we come to synthetic data. So I think the best example of synthetic data is the following. So these images looks like people, just like you and me. However, what's interesting here is that these people do not exist, but rather they have been generated by a computer program. So people have been using machine learning, and usually have one particular set of method called generative adversarial networks, GANs. And then you train these generative models on real data. So you basically take a large number of real faces, you learn a model based on this, and then this model is capable of generating new instances, in this case new faces, that should be as close as, I mean, for all means and purposes, indistinguishable from a real face, with the added advantage that there is no person that really looks like this. So there is no person whose personal integrity or privacy we could be invading. So therefore, that's kind of the general idea here. And one particular interesting application could be the medical domain. So again, the medical domain is one where we really need the real data from real patients. We cannot look at statistical individuals that don't really exist, but we need the real individuals with all their different combinations of features. And one question is, can we use these kind of techniques to be able to learn a model of how a patient would look like, and then generating synthetic patients and using them to improve medical diagnosis or treatments and so on and so forth. So the approach that we are taking is that we have the sensitive real data at the start. Then we use machine learning to learn a generative model that captures the distribution of this data. So we want to learn the significant features of this data. And then we can sample or generate data sets from this generative model. And these synthetic data sets should then both capture the salient features, so the important and features of the data, original data, and it should be non-sensitive, which means that it should not be possible to trace it back to the original data and so on and so forth. And then we need methods to verify that the accuracy of this synthetic data. We also need methods for verifying the non-sensitivity or the privacy preservation of this data. So that is what we're currently doing research on. As you saw in the previous slide, there has been results when it comes to images. And what we are interested in this particular case is actually about movements, which means that there's not just an individual image, but rather how individuals move over time. So we have all this temporal aspect, which adds another layer of complexity onto this. And of course, from a researcher perspective, I find this very interesting and very challenging, of course. So that's what we're working on. How can we extend these generative adversarial networks to learn not only the individual positions, for example, classification or something like that, but actually learning to generate sequences of real, believable, accurate enough movement, so that we can use it, for example, to improve the Telia Crowd Insight, so that we can provide Malmö Stad with better insights on how to make their city even better. So what we want to do is then to maintain privacy while increasing the spatial and temporal granularity. So can we go down to smaller grids? Can we produce information for shorter time periods? Can we also improve the accuracy for smaller groups? And maybe we can also reduce the need for data, so we don't need to use as much data, and thereby even further improving the privacy of these solutions. So the main message is that trustworthy and sustainable AI is absolutely necessary. And modern AI techniques require real data to really work and provide value. But using real data raises concerns regarding fairness, bias, and privacy. Synthetic data is one approach that we strongly believe can be used with great success to preserve the privacy and probably also to improve the fairness and reduce the bias. And all of this would not be possible to do this work unless we had this collaboration under the umbrella of the AI Sustainability Center, working together with Telia Company, Malmö Stad, and of course my team here at Linköping University. So thank you very much for listening and have a great day. Thank you and bye.